Okay, so here is lesson 1 about probability, and this is from unit 7, which is also titled Probability. Just a few vocabulary words that we need to get used to in this unit. When we're talking about probability, we're talking about chances. What are the chances of something happening? So that something is actually called an event. Okay, an event is an occurrence of something when something happens, like maybe rolling a 6 on a single dice. Or probability of an event is the chances of an event happening. We'll study this in this unit. Random is that every event has an equal likelihood of happening. And then sample space is a collection of all possible outcomes. For example, like when you're rolling a dice, you know that there's 6 outcomes. You can roll a 1, you can roll a 2, 3, 4, or a 5, or a 6. We call that the sample space. Probability distribution is the all possible probabilities, like how the probabilities are distributed. Theoretical probability is determined by mathematical examination of all possible values. So we just think about all the different possible things that could happen in an event. And then experimental probability is determined by relative frequencies determined in an experiment. So we're actually trying to like flip a coin and trying to figure out probability or something like that. So here, there's some things about probability that we need to be familiar with is that the sum of the probability of all possible events must be equal to 1. Okay, so for example, this right here sum means when you add up all the probabilities, it equals to 1. So for example, like I said, let's say that let's say you're flipping a coin. Okay, flipping a coin. It has 2 sides. It has a heads. So here's the sample space. So the sample space would be heads or tails. Okay, so the total outcomes that we can have is 2. So that 2 goes in the denominator. So the probability, let's write it like this. So the probability of rolling a heads is equal to, so there's only 1 heads on a coin and then 1 out of 2. And then the probability of rolling a tails is also equal to 1 out of 2. So when we add them up, 1 over 2 plus 1 over 2 is half plus half is equal to 1. So that's what that means. All possible events. Probability of any single event happening must be between 0 and 1. 0, I'll come back to this, but 0 represents impossibility, like it just won't happen. That is equal to 0. Or 100% certain it's going to happen, that's equal to 1. So all probabilities lie between not happening and 100% happening. Okay? So probabilities usually have a decimal, like 0 point something. That's usually what the answer looks like. And then more about theoretical probability and then experimental probability. So the equation is, how we calculate it is the number of outcomes in an event divided by the total number of all possible outcomes. And then experimental probability is number of observed occurrences of an event divided by the total number of outcomes. Okay, so we'll look at these as well. So for our first example right here, we have this little activity. It says here, the study of probability began with mathematical problems arising from games of chance. In 1860, Italian Girolamo Cardano wrote a book about games of chance. This book is considered to be the first written on probability. 2 French mathematicians, Pascal and Fermat, are credited by many historians with the foundings of probability theory. So they exchanged ideas on probability theory in games of chance and worked together on the geometry of the die. Die meaning like the dice, the 6-sided dice. Although probability is most often associated with game of chance, probability is used today in a wide range of areas, including insurance, opinion polls, elections, genetics, weather forecasting, medicine, industrial quality control. Okay? So we're going to look at this example. So complete the following table, which lists years of service of 789 workers at a high-tech manufacturing. All right, so we have this here. So we have males who've been there for, their seniority is less than a year. So they have 82 males have been there less than a year. 361 males have been there 1 to 10 years, more than 10 years, and then female numbers are here. So let's go ahead and fill out this, complete this table. So when it's talking about the total, it's talking about the males here. So let me bring up Desmos really quick. Just gonna use it on my phone here. So I'm just gonna calculate all this. So you have here 82 plus 361 plus 47. So that came out to 490 total men here, male. What about the females? Let's see, 49 plus 202 plus 48 is equal to 299. And then let's go ahead and collect all the numbers for less than a year. So we're just going to do all of that. 82 plus 49 is equal to 131. And then you guys get the idea. So let me just quickly get those. So 361 plus 202, I got 563. 47 plus 48, 95, and then we're just going to put the total here. So 490 plus 299, I got 789, and then I'm sure if you calculate this column, you'll also get 789. If you want, you can check. All right, so here it says, what is the total number of males? So the males is right here. So there are 490 total number of, oh, sorry, you can't see that, males. Where's the total number of workers within 1 to 10 years? So 1 to 10 years is 563. Okay, so now we're going to convert the table to a table of relative frequencies. So what we're going to do is we're going to take each of these numbers and we're going to convert them into a frequency. For example, this number right here is 82 divided by the total. So 82 divided by 789, which is equal to 0.104. So we're going to do that with the rest of them. So you're going to do 361 I mean, divided by the total, which was 789. So that is, we can go ahead and round this off. So this is 0.4, how many digits? 3 digits? Okay, so that's 0.45, and then I round it up to 8. And then same thing here. So you have 47 divided by the total, which is 789. So that is 0.059 goes to a 0, which means that this 5 changes to a 6, so 0.06. So whenever you have something like that, you really don't need to write that extra 0. And then over here, there's a couple of ways you can do this. You can do the 490 right here divided by the total, which is 789, 0.621, or you can just add these up right here, and you'll probably get the same number. Let's see. It's 0.0104 plus 0.458 plus 0.06, you should get around the same. And we kind of did. Okay. Almost the same. Okay, so we'll just keep going with this. So you have 49 divided by 789. Oops. 49 divided by 789, which is 0.062. Did I do that right? Oh yeah, it's the, okay. 202 divided by 789, 0.256, and so on. Alright guys, so this last one here, I mean, this is going to be 1. So like if we were to add these two columns up, we should at least get close to 1. Let's check. So if I had 0.621 plus 0.379, that's equal to 1. That's actually perfectly 1. Same thing here, if you were to add up this column, you will be equal to 1. So now we can go ahead and figure out what the probability is for each of these occurrences, okay? Each of these events. So let's say if a person is randomly selected from this company, what is the probability that they are a male? Well, the probability that they are a male is 6 right here. Probability that they are a male is equal to, there's a couple of ways we can write this. We can say it is 490 divided by 789. Which is equal to this right here, which we spent all that time calculating. So that is my probability of someone being male and from this company. What about they have less than 1 year of experience, so which is over here. So we can say, what is the probability of less than 1 year? Well, again, a couple of ways we can do that. So less than 1 year is 131 over the total, which is 789, which is equal to this one right here. We just do 0.166. That is the probability. Both are fine. Either you can give it as a fraction or give it as a decimal. What about they have more than 10-year experience? Okay, more than 10 year is this right here. So what is the probability of more than 10 years? Well, again, you can say more than 10 years, 95 over the total, or you can give it the decimal, I mean. Okay. What is the probability that they don't work for the company? Well, they didn't really talk to anybody who doesn't work for the company. So the probability that they don't work for the company is equal to 0. So they all work for the company, I think. Yeah. Okay, and then finally, just going to quickly go through this one. It says, using a 6-sided dice, answer the following. What is the probability of rolling a 6? So let's look at our sample space here. Sometimes when the outcomes are not like so many, we can look at the sample space. So the sample space for rolling a dice is, you can roll a 1, you can roll a 2, 3, 4, 5, and 6. So if we want to roll a 6, there's only 1 6, and then the total number in the sample space are 6 places, 3, 4, 5, 6, so 1 out of 6. If you want to convert it into a decimal, we can. So you just do 1 divided by 6 is equal to 0.16 and then round it up to 7. What is the probability of rolling an even number? So in our sample space, we have an even number 2, 4, and 6. So there are 3 chances here. So that is 3 out of the total, which is 6. And we can reduce that. So we can say that this is the same as 1 out of 2. Or we know that this is 50%. So 5. Another way that we write probability is we write it as a fraction, first way, then we write it as a decimal, and we also sometimes write it as a percentage. So to write it as a percentage, we just move the decimal place over twice. So this would be 16.7% of chance happening. So here we will move it over twice, so this is 50% chance of it happening. What about rolling a 1 or a 2? So that is 2 out of 6, which is the same as 1/3. And then if you want to convert that into a decimal, so 1 divided by 3, 1 divided by 3 is 0.333. And that is about 33%. What about rolling an odd number? So there's 1, it's 2, so 1 is an odd, so this is the same as rolling an even, right? 3 out of 6, which is the same as 1 out of 2, which is 50%, 0.5, which is the same as 50% chance. Okay, example 2, identify the problems with each of the following. So basically we have these probabilities here and we just need to identify what is wrong with them. Alright, so the first one, the probability of A is 0.35, 0.40, and 0.35 again. Well, if these are all the possible outcomes, they should equal to 1. 35 plus 0.4 plus 0.35. It's over 1. It's a little over 1. So they do not sum up to 1. The sum is more than 1, which cannot be when you're doing probability. The second one, let's see what happens here. Same thing here. If you add them up, so you have 20, whoops, not same thing, maybe it's a little under, plus 0.5 plus 0.25, which is, it's under, okay? They have to equal to 1. Same thing. Does not, I should say not, do not, does not, does not, does not. Sum up to 1. The sum is less than 1. Here we have a probability of 1.2. That itself tells you that it's more than 1. We can just say the probability of A is more than 1. That is a problem. Again, it's telling you to identify the problems. More than 1. And then over here, this negative, you cannot have it. The probability of B is negative. That cannot happen as well, because it has to be between 0 and 1. That is the problem. Okay? So, the main things that I want you to understand from this lesson is the sum of all the probabilities has to equal 1. The probabilities of each event, of any single event, has to be between 0 and 1. Usually like when it's like 0 point something. The probability of something of being impossible is 0, and the probability of something being certain is 1. That's the actual probabilities. And then these two right here. You just take the total number and then you put that in the denominator, and then the number of outcomes you're interested in, it goes in the numerator. Okay?